Alright, if you guys could please turn to 7.6, apply the sine and cosine ratios. Alright. Sine and cosine are trigonometric ratios for the acute angles that involve the length of a leg and the hypotenuse of a right triangle. Okay? Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Now, I will probably mention this in class if I haven't done so already. SOHCAHTOA is a really, really good way of memorizing all three trig functions. Okay? So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. So if you can memorize just this word, you have all three trig functions memorized. Okay? Alright. Angle of elevation and angle of depression. When looking up at an object, the angle your line of sight makes with a horizontal line is called the angle of elevation. So if this is the horizontal line, and you're looking up this way, this is your angle of elevation. If you're looking down at an object, the angle your line of sight makes with a horizontal line is called the angle of depression. So if this is a horizontal line, then this, if you're looking down, is your angle of depression. Alright, sine and cosine ratios. Like I said, sine is opposite over hypotenuse. So in this case, if you're looking for sine of A, the opposite side would be BC. And the hypotenuse is AC. Cosine is adjacent over hypotenuse. The adjacent side is AB. And the hypotenuse is still AC. Alright, let's go on to page 2. Find sine of U and sine of W. Write each answer as a fraction and as a decimal rounded to 4 places. Alright, so sine of U. Opposite over hypotenuse. The side opposite U is 16. Actually, let's write this first. WV. The hypotenuse is WU. WV is 16. WU is 34. This can be simplified. If I divide top and bottom by 2, I get 8 over 17. Let's pull out a calculator. Eight divided by 17. 0.4706. Alright, so let's take a look at sine of W. Sine of W, this is the opposite side. So I've got UV, and still WU is the hypotenuse. UV is 30. The hypotenuse is 34. If you divide top and bottom by 2, you get 15 over 17. Hopefully you guys see that this is an 8, 15, 17 triangle. 8, 15, 17 is a common Pythagorean triple. So 15 divided by 17, 0.8824. Alright, let's go on to the next one. Alright, cosine is adjacent over hypotenuse. Let's go back to blue. So cosine of S, this is the opposite, which makes 45 the adjacent. So ST is the adjacent, SR is the hypotenuse, ST is 45, SR is 53. You can't simplify that. Let's get our calculator out. 45 divided by 53. 0.8491. Alright. Cosine of R. In this case, 45 is the opposite, so 28 is the adjacent. That's TR, or RT. RT is 28. This is still 53. Let's pull the calculator out again. 0.5283. Alright, I'll let you guys do this checkpoint. Let's go on to page 3. Okay, you walk from one corner of a basketball court to the opposite corner. Write and solve a proportion using a trigonometric ratio to approximate the distance of the walk. Alright, so this is our situation. You walk from here to here. This is 62 degrees. The opposite side is 94 feet. We're looking for this one. So, this one is the opposite side, and we know that x is the hypotenuse of our right triangle. Opposite and hypotenuse. You're going to use sine, because sine is the one that involves opposite and hypotenuse. So sine of 62 is going to be, well, let's write this first, opposite over hypotenuse. The opposite side is 94. The hypotenuse is x. I'm going to multiply each side by x. Now I'm going to divide each side by sine of 62. Alright, now I'm going to pull out my calculator. Alright. 94 divided by sine of, oh, you know what, before I do this, make sure you are in degrees. Very important. Okay. 94 divided by sine of 62. 106, 0.46. Actually, I think they wanted us to do this first. (94) sine of 62 degrees is 0.8829. That's sine of 62 degrees. Well, and then when you divide this, that's when you get 106.5. So the distance of the walk is about 106.5 feet. Alright, example 4. You are at the top of a roller coaster 100 feet above the ground. The angle of depression, that was one of our vocab, is 44 degrees. That's this angle here. About how far do you ride down the hill? Okay, so once again, this is the opposite side, and this is the hypotenuse. Opposite and hypotenuse. Think SOHCAHTOA. Again, we're going to use sine. So, sine of 44 degrees. Opposite over hypotenuse. The opposite side is 100. The hypotenuse is x. I'm going to multiply each side by x, so I have x times sine of 44 degrees equals 100. I'm going to divide each side by sine of 44 degrees. So 100 over sine of 44. Pull out my calculator. Oop, turned off. Let's try again. Yeah. Okay. Clear mode degrees. There we go. Okay, so sine of 44 degrees, 0.6946, or 47 rather. And that is sine of 44 degrees. Then when we divide that, (143.94). or I'll just put 143.9. So you write down, you write about 143.9 feet down the hill. Alright, let's go on to page 4. Okay, you guys can do the checkpoint. Example 5. A railroad crossing arm that is 20 feet long is stuck with an angle of elevation of 35 degrees. Find the lengths of x and y. Okay, so here's our situation. Let's solve for x first. X is the opposite side. 20, the only length we're given, is the hypotenuse. So, Katoa, we have opposite and hypotenuse. We're going to use sine. So, sine of 35 degrees is opposite over hypotenuse. We're going to write the ratio for, let's see here. I guess I want you to write out the whole thing. Sine of 35 degrees. Seems kind of weird. Alright. Sine of 35 degrees. The opposite side is x. The hypotenuse is 20. I'm going to multiply each side by 20. So now I have 20 times sine of 35 degrees. I'm going to pull out my calculator. Turned off again, of course. Let's try again. Okay, so 20 times sine 35 degrees. Yep. There we go. 11.47. I'll put 11.5. Alright, so now let's solve for y. I'm going to change colors. Y is the adjacent. 20 is still the hypotenuse. So now that we're dealing with adjacent and hypotenuse, we got cosine. Cosine of 35 degrees, we're going to write the ratio for cosine of 35 degrees. Cosine of 35 degrees. The adjacent side is y, hypotenuse is 20. Multiply each side by 20. Okay, let's pull out the calculator. 20 times cosine of 35 degrees. 16.38 or 16.4. Okay, last page. Alright, use a special right triangle to find the sine and cosine of a 30-degree angle. We're going to use the 30, 60, 90 triangle theorem to draw a right triangle with side lengths 1, root 3, and 2. Okay? Now, the reason we're doing this, if you remember, in a 30, 60, 90 triangle, the hypotenuse is 2 times the short leg, and the long leg is root 3 times the short leg. So in this case, because the hypotenuse is double the short leg and the long leg is root 3 times the short leg, you know this has to make a 30, 60, 90 triangle. And since they don't specify what kind of 30, 60, 90 triangle, this one will work. Sine of 30 degrees, this is opposite over hypotenuse. The opposite side from 30 degrees is 1. The hypotenuse is 2. This is about 1.5. Actually, it's exactly 1.5. Cosine adjacent over hypotenuse. The adjacent side is root 3. The hypotenuse is still 2. If you plug this into your calculator, you're going to get 0.8660. Alright, you guys have the checkpoint, and that's all.